Okay, so today we're going to be talking about covalent compounds and naming. Our last lesson we talked about naming ionic compounds, so today we're going to talk about a different type of compound called a covalent compound. Alright, so just as a quick review, remember that ionic bonding is the transfer of electrons between atoms, and that's what's going to be different when we're talking about covalent bonding. Alright, the ionic bonding consists of a metal cation and a non-metal anion. Okay, and as we talked about last week, the metal cation, which has a positive charge, and the non-metal anion, which has a negative charge, are attracted to each other. We've all heard the old adage that opposites attract, and that's exactly what happens here. Okay, and those ions come together to form crystal lattices. Okay, and what a crystal lattice is, and we talked about this in the last lesson, is basically just an arrangement of the atoms in a specific shape. So whether it's in a cube or a pyramid or an octagon or all sorts of different shapes. So the difference with covalent bonding is that covalent bonding is the sharing of electrons between two atoms. Instead of the electrons being transferred, like one from sodium being transferred to chloride, the electrons are actually shared between the atoms. Okay, and the other major difference, and this is how we're going to be able to tell the difference between covalent compounds and ionic compounds, is that covalent compounds have no metals in them whatsoever. The bond is between two non-metals. Okay, so that's something very important to remember, and it's something that's going to come in very handy when we start assessing you on your tests and quizzes. So make sure that you make a note of that, star it, or do whatever you need to do to remember that. But this right here is key. So do not forget that. All right, make sure you star it, circle it, underline it 500 times if you have to. These atoms in the covalent bonds will still follow the octet rule. That's not going to be any different. Remember when we talked about stability of atoms, we talked about the octet rule. And instead of the electrons being transferred in order to establish those stable octets, these atoms will share them. Okay, and it's going to be quite a bit different, and when we start talking about drawing the structures of these covalent compounds, it's going to be kind of tough to get used to, but as long as you understand the octet rule, you should be okay for the next week or so. Alright, so how do we name covalent compounds? We're not going to worry right now about how to recognize them. We just want to know how to name them. Alright, so there's 6 steps to naming a covalent compound, and the first is to use prefixes to denote the number of atoms for each element. Okay, and these prefixes will match the subscripts that are in a formula. And for those of you that have forgotten what a subscript is, that's the tiny number or letters or whatever that you see to the bottom of a word, or letter or symbol or whatever it is. So with something like CaCl2, this 2 right here is the subscript. Alright, so the first element will have its same first name. That's not going to change. There will be no changing of the stem or anything like that, so it's going to stay as its full name. Alright, so carbon would stay carbon, and silicon would stay silicon, and nitrogen would stay nitrogen, and so on and so forth. Okay, it's going to be the second element that is going to change, and its stem or its root name for that element will actually add the ending IDE. Okay, so just like we talked about with the anion endings for ionic bonding, the endings for the second element in a covalent compound are going to do the very same thing. So, chlorine would become chloride, and fluorine would be fluoride, and carbon would become carbide, and silicon would become silicide, and astatine would become astatide, and sulfur becomes sulfide, and boron becomes boride, and you can keep going and going and going with all of these non-metals as long as they're the second element in this compound. Alright, so let's look at steps 4 through 6. The prefix mono is never used on the first element. Okay, it may seem kind of confusing in the beginning, but when we do a couple of examples, you should be able to pick up on it fairly quickly. So that prefix mono is never used for the first element. We don't talk about monocarbon monoxide. Okay, we just leave that mono prefix off of the first element. The second element will only use the prefix mono if it is oxygen. Okay, so there's no mononitride if it's the second element. All right, the only time we'll use mono is basically if oxygen is the second element. Okay, and then finally the last rule is the vowel at the end of the prefix. So whatever prefix you use, the vowel at the end of that prefix is dropped if we're using oxygen. Okay, so if you had something like mono and oxide, you would drop the O on mono and it would be monoxide. We'll do a couple of examples here to get you familiar with how to do this. Okay, but first let's take a look at subscripts and what they're telling us. So these subscripts, as we said, were placed to the bottom right of the element symbols and tell you how many of each atom there are. Okay, and the other thing that they're actually going to tell us, and we'll talk about this when we get into Chapter 10, is those can actually also stand for not only the number of atoms, but the number of moles of that element in 1 mole of that compound. So that'll make a little bit more sense when we start getting into Chapter 10. So our example of N2O3, that tells us that there are 2 nitrogens and 3 oxygens, and then CH4 tells us that there is 1 carbon and 4 hydrogens. Remembering that the subscript 1 is understood and not written. All right, so here's the prefixes. I'm going to take a second to let you write these down. So make sure you get all 1 through 10. So hit pause, and when you have all of these written down, continue on. All right, so here is the kind of the formula, I guess, for writing the name of a covalent compound. Okay, so I'm going to get my little arrow out here and show you kind of exactly what I'm talking about. All right, so here is the first element right here. Okay, so remember the name of the first element does not change. Okay, so whatever it is, you keep the name the same, do not change anything. And then whatever subscript corresponds to that element, you will put the corresponding prefix in front right here. Okay? Remember, never mono. Never mono here in the front. Okay, do not forget that. Okay, mono, bad for the first element. All right, and then the second element, remember that's the element and changing the ending to IDE. We talked about that earlier. And then also you'll look at the subscript of the second element and put the corresponding prefix in front. Okay, so if you're having kind of trouble recognizing what those IDE endings are, make sure you look at your ion sheet, and that'll give you kind of some insight into the IDEs that we're going to be using pretty much for the rest of the year. Okay, so I'm going to do some examples here with you. So let me get my pen out here. Okay, so let's follow the formula that we just talked about. So the first element here is hydrogen. Okay, so we're not going to change the name, so we'll just put hydrogen. My writing is awful.
Do you want me to write today?
Okay, so I'm going to erase that. We're going to try that again because
I'll write for you.
Mr. Herzog's going to edit this out.
Yeah.
Okay, so let's do our first example here, H2O, which we all know is called water, but I guarantee if you guys saw this on the test, you would try to use a covalent name with it. I've seen it all the time. All right, so the first element is hydrogen, so we're not going to change the name. All right, so we'll write hydrogen, and the subscript that goes with hydrogen is 2. And the corresponding prefix is di. Okay, so we'll go ahead and put the prefix out in front. So we've taken care of hydrogen. All right, that's dihydrogen. Now we're moving on to the second element, which is oxygen. All right, and we change the ending of oxygen to oxide. Okay, and right here there is no subscript. Okay, it's blank. So we use that as an understood 1. Okay, not a 0, but an understood 1. And the prefix for 1 is mono. But like we said in our rules, if we have a prefix that ends in a vowel that we're using with oxide, we go ahead and drop the last vowel. So instead of monoxide, we should write just monoxide. Okay, so let's look at example number 2. First element in example number 2 is carbon, so I'm going to go ahead and write carbon down. Remember, we don't change the name. And the prefix for the understood 1 that is right here is mono. But if you remember our rules, we never start off with mono. So we're just going to go ahead and leave that blank. Okay, so the second element is oxygen. So once again, we will change that to oxide. And here is the subscript, 2. All right, and the corresponding prefix for 2 is di. So we will go ahead and put the di in there. And the name for CO2 is carbon dioxide. Okay, and a lot of you are probably sitting there thinking, wait a minute, I thought we had to drop the vowel if it's with oxide. Well, that's only for prefixes that end in A or O. All right, so di does not count in that instance. Okay, so let's take a look at the last example. All right, so once again, our first element, we don't change the name on, so that's nitrogen. Okay, and the corresponding prefix is 1. Or I'm sorry, the corresponding prefix is mono, since we have an understood 1 here. But remember, we don't write mono, so we're going to edit or leave that out. Okay, so our second is hydrogen, and that gets changed to hydride. Okay, and the subscript is 3, and the corresponding prefix is tri. So we'll put our prefix in there, and we have nitrogen trihydride. Now, the interesting thing about covalent compounds and their naming is that some of them actually go by what we call common names. You know, like dihydrogen monoxide. You don't go around hearing people talk about dihydrogen monoxide. They talk about water. Okay, and then NH3 is actually called ammonia. And CH4, which we saw earlier, carbon tetrahydride, is actually called methane. So a lot of these covalent compounds have more common names that they're known to by, but we're only going to learn this way, and you're only going to be responsible for this type of naming. So it's now your turn. I've got 4 examples here, and these are the 4 examples that I want you to go ahead and try to name. And then after that, we'll talk about those in class the next day. All right, so make sure you try these. Bring your questions to class the next day that we are in session. Okay, just as a helpful hint, down here in example number 3 right here, this is Cl, not Ci. Okay, this is a chlorine right here. Okay, so try to name these 4, and we will see you in class the next day.